Hello everyone, I am Musab Hamdan, a research assistant in the Smart Grid Lab at German Jordanian University. And I will be moderating this webinar. And welcome to today's webinar, Peer-to-Peer Electricity Trading in Microgrids Platform Launching. German Jordanian University, in partnership with the Newcastle University and Ibtikar Consulting, is organizing this webinar, which aims to introduce the attendees to energy trading in microgrids and the available business models in the market. In addition to presenting the research project outcomes, including the research publication, business model study, teaching modules, and launching the electricity trading platform. Before we get started, I would like to go over a few items, so you know how to participate in today's event. We will take a screenshot of the attendee interface for the certificate of attendance purpose. So please rename your account name as you wish to be appeared in the certificate of attendance. You will have the opportunity to submit text questions to today's presenters by typing your questions into the chat area. You may send in your questions at any time during the presentation. We will collect these and address them at the end of the presentations in the open discussion. I would now like to introduce our presenter, Professor Alauddin Al-Halpouli, the GGU president, to open this webinar and give us introduction to the energy projects and the partnership. Professor Ala, make sure you are unmuted and begin, please.
Good evening, everybody. I'm happy to be with you today in the capacity of the president of the German Jordanian University, but also as a leader of this project, peer-to-peer electricity trading in microgrids platform, which is in collaboration with the University of Newcastle and Ibtikar. I'm happy actually to introduce the team. Ibtikar is represented by Jamil Al-Khatib. The University of Newcastle is represented by Dr. Adib Al-Laham. And we have our JGU team, Engineer Musab, Engineer Mohammed Al-Mahmoudi, Engineer Dr. Makkawi Hriz. We have also Engineer Asma, and previously we had Engineer Osama and Engineer Mustafa. Many engineers worked in this project, and it's a new technology here in Jordan, but actually it's already applied elsewhere in the UK, in Germany, and other companies and countries. So we try to be pioneers in energy trading in Jordan, and we are now reaching the closing of this project. The project is supported by the Royal Academy of Engineering in the UK, and we got funding for the last 3 years on this project. We hope that you will enjoy this seminar, and you are asked also to contact us, connect with us at the lab. We named it as now a Smart Grid Lab. In the university here, we have also other groups like the group of Dr. Osama Saadi and Dr. Zakaria Dalala, who are working also on this topic. We have Dr. Ahmed, and we hope that we will soon join efforts to work on, let's say, smart grid lab that serves the strategies of Jordan and the region. In the lab, we have also different other projects other than peer-to-peer electricity sharing project. We do have another one with Mouta University, Dr. Khalid Al-Awasa, about decarbonization Jordanian energy systems utilizing smart solutions based on energy storage. Another project in the lab, and we are leaders also with the University of Newcastle, is the digital twin software to control part of Jordanian electrical networks with considering the cybersecurity aspect. The project is running till April 2023. We had also Erasmus Plus project on advanced teaching and training on smart grid and grid integration of renewable energy systems. And we have a real-time simulator in our lab where you can simulate microgrid or large grids. We do have also another project in modeling and simulation distributed energy resources in smart grid management and optimization. There are two other projects on the development of higher education teaching modules on the socio-economic impacts of the renewable energy implementations and development of environmental engineering courses and impact of climate change concept for undergraduate curriculum. These are all projects where we were a leader in these projects or partners, mostly with European, let's say, partners, and we had partners from Syria, from Egypt, from Morocco, from Cyprus. So different countries were involved in these projects, but still the main partner now for the peer-to-peer and for the digital twin projects are the friends from the University of Newcastle. I wish you a very successful meeting, workshop, and hopefully we will keep in touch and utilize the capacities available at the German Georgian University for extending these ideas and projects towards implementation and impact on the society. Look forward to hear about the recommendations of this meeting and wish you good luck. Thank you very much.
Thank you, Professor Alauddin Al-Halhouli. Now, let's please welcome our first presenter, Engineer Asma Al-Khribat, a research assistant in the Smart Grid Lab at German Jordanian University. She got her master's degree in computer engineering from GJU with a thesis titled Real-Time Implementation and Monitoring of Microgrids in Microgrids. And she is working now on project with title of Modeling and Simulation Distributed Energy Resources in Smart Grid Management and Optimization. So she will give us introduction to this subject.
Engineer Musab, if you give me just one moment, I forgot to mention Dr. Hani Mohsen. He is a main partner in the Smart Grid Lab, and he is also leading this project with Engineer Asma and his partner in all other projects. So many thanks for all colleagues.
Thank you, Dr. Ala, and sure you are welcome, Dr. Hani. Engineer Asma, you can begin your presentation, so please.
Thank you, Musab. Good afternoon, all. My name is Asma Khribat. I am electrical power engineer at Smart Grid Lab in German Jordanian University. Let me share my screen to start my presentation. So today I will talk about an introduction to the subject, or let's say a brief introduction to the subject, while my colleagues will talk in deep about the project and the main objective and activities of the project. I will start with the main outlines. Through this presentation, I will start with an introduction. I will talk also about market structure, smart grid concepts, also about the blockchain and how can we implement the blockchain in the smart grid, and also about the IoT, which is the Internet of Things concept, and also the implementation of the IoT in smart grid concept. So let's talk about the introduction. I will talk about two main subsections through this introduction, which are the existing policies and the future market structure. We know that recently there are distributed energy resources, several types of distributed energy resources that are integrated to the grid. And we know that in the end point of the electrical grid, in some cases there are surplus energy. So this surplus energy can be exchanged or sold, or let's say exchanged to the other networks through different policies. These policies could be classified into two main policies, which are net metering and feed-in tariff. So what are the main differences between these two policies? In the feed-in tariff policy, the surplus energy of the prosumers can be sold to the consumers at an, let's say, export price. So this export price for mostly is lower than the retail price, which are the price of buying electricity from the grid. So this is the main difference in feed-in tariff. While in net metering, the surplus energy at the prosumers end, let's say, can be transmitted to the grid, so it can be used in other months of the year. So in general, the main difference between those two policies or main existing policies is, let's say, it is the feed-in tariff are not linked directly to the value of the consumers pay for energy. So it is mainly lower than the price of the grid. Related to market structure, we can classify the future market structure based on level of decentralization into three main types, which are a full peer-to-peer, a hybrid market, and community-based market. This figure here represents the first type, which is a full peer-to-peer market. In this type, the peers trade energy directly without the needing of the mediator or the aggregator. So the peers are, let's say, communicated between each other to trade energy. No need for aggregator in this type. While in the second type, which is community-based market, here we can see that there is aggregator or mediator that organize the trading process. So this aggregator will receive that data from participants, also will organize the selling and buying deals, will balance the supply and demand in the network. So it has the main things here in this type. While in the hybrid market, it is a hybrid type of both previously mentioned types. In this type, the peer has the ability to choose whether to trade energy through the mediator or between each other. The second concept that I will talk about is the smart grid concept. We know that the smart grid is a concept for transforming the electrical power grid by using advanced and automatic control and communication techniques and other forms of information technology. And we know that the smart grid integrate innovative tools and technologies in different sides, in the generation, in the transmission, and even in the distribution, using advanced equipment. There are few, let's say, I will talk about four main concepts under the smart grid umbrella, which are the dynamic pricing. So in smart grid, there is no fixed pricing of the electricity. Also smart meter, which is important in case of the bidirectional energy. So it helps the consumers to know what is the energy coming out of, coming from the grid. Also the energy moved from the prosumer or the consumer side to the grid. Also, the microgrid considers one of the main application of the smart grid. It's a small scale of smart grid system that has or that consists of a mix of generation types, mainly renewable, wind or PV or other types of renewable energy. And the main, as I said, the main interesting point in the smart grid that there's a different type of distribution generation, mainly the renewable energy integration. The second concept that I will talk about through this presentation is the blockchain. We know that the blockchain is a shared ledger that facilitates the process of recording transactions. So it is provide a recording for the transaction and provide a cryptographical transaction, a secure transaction for sure. And also blockchain may be characterized as a platform where peers can exchange value through transaction without even a requirement for a centralized control or a centralized trusted point. So here, by seeing this figure, we can see that all the transactions will be secured using a hash function, as several types of hash functions, and also these transactions will be at all the peers. So all the peers will know about these transactions and in a secure way, for sure. So here is the blockchain of smart energy. Here's the, let's say there are important steps in the blockchain. I will go through it through these steps. First step, that the blockchain has a smart contract as shown in the figure, and then the available energy at the prosumers or at a seller side will be advertised to other peers. Then the prosumers will maintains the track on the blockchain, and all the prosumers will respond with a bid. Then the winner bids out of the auction based on the applied auction or the implemented auction will be determined using the smart contract that's available in the first step. Then this peer will distribute the reward. Then the energy will distribute it to the prosumer as shown in the step 5. And in step 6, the transaction will begin, and the final stage, the transaction has been settled upon and the funds have been transferred. So this is, or let's say this is the process of applying the blockchain of a smart energy in the energy trade process. The final concept that I will talk about is the Internet of Things. We know that the Internet of Things can define as a massive network of interconnected items. These items could be small devices, machines, or even people. So IoT is a well-known concept that is utilized in different areas. Here I will talk about how can we implement the IoT based on a smart grid overview. We know that Internet of Things can support technologies or multiple technologies in a smart grid. Comprehensive sensing and processing abilities of IoT can improve the smart grid abilities, such as processing, self-healing, also the recovery and reliability. So in general, the combination between the Internet of Things and the smart grid can greatly promote the development of smart terminals, meters, sensors, even information equipment, and for sure in the communication devices as well. IoT also can be used to accomplish or to acquire the reliable data transmission in both wire or wireless communication infrastructure in different parts of smart grid, even in the markets, in generation, in transmission, in distribution. I will give an example. For example, in the electricity generation, IoT can be used to, let's say, to monitor electricity generation of different kinds of power plants, such as wind, solar, biomass, etc. Also, IoT can be used to acquire electricity consumption dispatch, monitor and protect also the transmission line as shown in the figures. We can say also the IoT can be used even in customer side, in the endpoint side, in a smart meter to measure different type of parameters, also to measure consumption, power consumption, even in charging and discharging electrical vehicle in case of using the electrical vehicle. And also it can be used to manage energy efficiency and power demand. So I go through these concepts, starting with the the policies used in trading energy, and also the structure or the future market structure. I talked about also the smart grid and how can we implement the blockchain and IoT in the smart grid. I hope that I introduced this concept in a simplified way, and I hope you enjoy it. Thank you.
Thank you, Engineer Asma. Now let's please welcome our second presenter, Engineer Mohammed Mahmoudi. He received a bachelor's degree from Yarmouk University in Jordan in electrical power engineering and followed up a master's degree in mechanical engineering, renewable energy at the University of Jordan. Currently, he is a research assistant at the German Jordanian University Smart Grid Lab. The research interests are mainly in smart grid applications and renewable energy resources, particularly wind energy, photovoltaic systems, storage systems, and related topics from an electrical and mechanical point of view. Engineer Mohammed will present the project activities and outcomes. Engineer Mohammed, please begin.
Hi, everyone. Thank you, Musab, and I would like to thank the attendees for attending this closing webinar of peer-to-peer energy trading and launching the platform. First of all, I will take you through the following outline, starting by please. I want 1 minute only to charge everything. I want to take you through the introduction, which contains a list of achievements. Then we'll also introduce an overview about smart meter, business model, novel algorithm that has been developed during the project period, and the trading platform that also has been built and it is launching today. Finally, we will also talk about the course material. First of all, we'll talk about the hackathons, webinars, and internships. Energy digitalization webinar or energy digitalization was discussed in a webinar and hackathon. The energy digitalization hackathon was held in the interval between 16 and 23 of November 2020 with the participation of 64 students and young professionals from different universities and companies. 4 prizes were awarded to the best 3 local teams and international teams. The hackathon was conducted to promote the concept of digitalization of the electricity sector, taking peer-to-peer energy sharing as an example. The energy digitalization webinar was held and took place in 16 of November 2020 with the participation of different stakeholders representing the governmental and non-governmental authorities and research centers and research authorities. The focus of the webinar is to identify the different challenges that are faced by distribution companies, as well as the private sector and the investors, stakeholders, and introduce the role of digitalization in solving the electricity issues. With regards to the internships, a team of bachelor students from Princess Sumaya University for Technology was engaged with the research activities and being monitored by the projects team and the project research team. The idea of the project as has been conducted by this team was about peer-to-peer electricity trading simulation under reliable and constraints using the MATLAB and Simulink. For more elaboration of these main achievements, I will go through the main achievements one by one, starting by smart meter fabrication. Smart meter fabrication is an application of IoT, and PCB board is appeared in the figures, PCB printed circuit board and PCB after assembling the components. ESP, which is a microcontroller, is used in this smart meter. It depends, and it was also adapts Wi-Fi and Bluetooth features to enable communication via internet between the end users, households, and the platform to transfer and record readings, or we can say live readings, and respond to the transaction process between peers in the microgrid. Before taking about the business model field and the achievements in this area, it is important to know that peer-to-peer can be divided into 4 different layers. We have different layers for peer-to-peer energy trading. The first one is the power grid layer. The second is the information and communication technology. And the third is the control layer. While the fourth layer, which is a very important layer, so-called business model layer. As we can see here in this figure, we have 3 different layers, which is the bidding layer, market clearing layer, and settlement. We can say that this is the phases of business model. The business layer is essential part for the peer-to-peer energy market that concerns maximizing participants' review. It includes, as we previously mentioned, bidding, which is the first phase when consumers and prosumers submit their own asks and bids. And then the second phase is the market clearing, when certain algorithm is employed in order to end up with the settlement, which is the third phase, when the surplus electricity in the network has sold and the all requests of electricity has been met also. In business model, bidding or market clearing, we need algorithms. So why we need algorithms, and where exactly algorithms are needed? There are 2 main uses of algorithm in trading process. The first one is in bidding stage, and the second is the market clearing stage. We have several terminologies in decision making and in algorithms that are very important when it comes to electricity trading, in peer-to-peer energy trading, or in decision making under uncertainty conditions. Game theory is one of the main and very important terminology, which is defined as the mathematical tool used to analyze the behavior of different participants in a competitive environment and give the proper result. The second terminology is the auction. Auction process is a market procedure which is based on the negotiation between peers in the market, which is this negotiation technique is between the bids and asks to specify the buyer of the items according to the bidding rules. This is the overview before demonstrating the publication or demonstrating the achievement. One of the main achievements in this area is the review paper that has been published in Sustainability. The title of it is Business Model of Peer-to-Peer Energy Trading, a review in the literature. And the contribution of this paper can be summarized as the following: review the innovative trading mechanism used in peer-to-peer energy market to investigate its efficiency and applicability. Then summarizing the main dimensions of the business model, market clearing approaches, and bidding strategies that researchers use to build business layer. The third one is reviewing the peer-to-peer trading policies of developing countries. And the fourth is a comprehensive classification or aspects of auction methods and game theoretical methods. And the fifth one is the offer to offer recommendations for the future work directions for business model developments and energy trading policies, considering developing countries as a main topic, because developing countries suffer from lack of policies in renewable energy and the energy market. The second publication, which is a drafted article, which is prepared for publication, entitled Electrical Losses Minimization, using a predictable auction-based market clearing algorithm for peer-to-peer electricity trading. And in this paper, we proposed an innovative market clearing strategy to minimize distribution network losses related to peer-to-peer energy trading and trading transactions. And the second contribution of this paper is to employ different mentoration level of renewable energy systems inside electrical grid on the trading process and associated trading losses. The influence of the prosumers location inside the community has been also studied in this article. Another important achievement is the trading platform. The trading platform, which is launching today, is an essential achievement that has been done during the project period. This platform enables subscribers to share their surplus electricity within the microgrid in Jordanian network. The consumers have to submit their energy request in kilowatt hour. After that, prosumers will give 3 offers to each request with requested energy and their total price. Once offers is approved by the aggregator, so we will have an aggregator who has to monitor the trading process. So once this aggregator approved, the consumer can select one of the nominated offers. The aggregator will accept only offers with certain losses range, and offers with high losses will be rejected by the aggregator automatically, and certain losses, certain limit of losses will be accepted and assigned by the aggregator. For example, 400 watt for a single phase and 2000 watt in 3 phase. Another achievement to be discussed is the course material. A course material is developed by Smart Grid team, and this course is designed to guide those interested in IoT, Internet of Things, and blockchain technology, especially in electrical engineering and smart electricity network. The course is divided into 8 chapters, beginning with the fundamentals and applications of IoT in everyday life, going through several IoT-based and blockchain-based architecture, characteristics, and protocols. Several terminologies related to Internet of Things and blockchain are discussed within the course, with explanations and examples. The Smart Grid Lab also conducted a study and chapters that discussed the concept of smart grid and the blockchain and the Internet of Things in smart grid, and how to employ Internet of Things and blockchain in energy market and electricity market, for example, smart meter and trading platform. A simple smart meter design procedure is also discussed within this course by providing design step by step in terms of equipments and requirements needed for the course participation to build the smart meter from scratch. Thank you for listening, and we will switch to the second subject. Thank you.
Thank you for excellent presentation, Engineer Muhammad. Dear attendees, if you have questions for Engineer Muhammad or any presenters, please add them in the chat area, and we will be able to answer them during the open discussion. Now I'm going to present the fourth topic. I am Musab Hamdan. I received a bachelor's degree from the University of Jordan in mechatronics engineering, and followed up a master's degree in computer engineering at the German Jordanian University. Currently, I am a research assistant at the Smart Grid Lab. Now I'm going to present the electricity trading platform. In this session, I will go through the platform and explain how consumers and prosumers are trading and what is the theoretical part the platform was built depending on. This is the website address, electricitytrading.jju.edu.jo. Starting with the platform design, the trading will consider IEEE 33 bus benchmark. So we will consider the distance between buses and resistance, which will be used to calculate the power losses, which is important for the market clearing phase. And the design could be modified according to any network. The second point is trading will be used on the lowest power losses among buses. The third point, the admin user is required to act as the aggregator. The responsibilities of the aggregator are as follows: identifying the bus location in the network and the number based on the location. The second, identifying the accepted losses range, and all bids and offers appear in admin user and can nominate to the buyer only that within the accepted range. Finally, the platform can adapt single and the three-phase users. Going to the platform, a short demonstration we can have here. This is the landing page. As we see, this is this area. We can see the news about the Smart Grid Lab and how to trade. And about our funding agency and our partners. The second page about the project, if you need to know more about the project outcomes and objectives, you can read from, we will put another information also in this page. The third page about the courses, blockchain and in smart grid labs and IoT. Here you can find the content and description, the lectures and quizzes and their answers. And in the future, we will go with the interactive interface. Now we will go to the important part, to the user of trading, firstly, you need to sign up and to put your name, email, country, city, and Google Map location, and how much meters you have in your home. After submission, you have to log in, put your email and password. And as shown in the right bottom, the smart meter connected with a load light bulb. And here is the main page, home page. You can add a new request. We have four tabs, main tabs: trading, my request, profile, and transactions. In trading tab, you can add a new request and you can see all the requests. For example, we need to put 1 kilowatt hour. If you want to request 1 kilowatt hour, you need to put the minimum and the maximum price and select the meter. Now the request added successfully. And going to the to another account user, he need to put to add a new offer. He put 1 kilowatt hour, the requested amount, and he submit successfully the offer. And we will go back to the first user, the requester, 1 kilowatt hour with these specifications. 0.7, the offer $0.7 per kilowatt hour. The offer accepted successfully, and within 15 seconds, the settlement will be refreshed. And as we see, the meter, the smart meter, turned on and connected. And here we can, as we can see here, in the profile page, you can add the meter and you can see how much the consumption, and you can start and can control your meters by starting or pause it or resume to control the consumption. This is our first case, and I would like to present another case. In this case, if the requester had an offer and there is power losses, it's disabled, and he cannot accept this offer, and he can accept only the first offer, which there is no high power losses. So that's it. This is our platform. We hope we can improve this platform in future, and thank you. Now, let's please welcome our presenter, Engineer Jamil Al-Khatib. Engineer Jamil holds a master's degree in technology and innovation management from Brandenburg and BTU in Germany. He started his career in innovation development side, where he was an R&D engineer who developed telecommunication devices for Siemens. He moved then to the field of innovation management and entrepreneurship, where he established a startup in the IT open source field, then consulting company in innovation management field, Iptikar. He established and managed the program Innovation and Entrepreneurship PIE at the German Jordanian University for more than 8 years. Engineer Jamil will present the development of a business model for the service provider in the framework of electricity trading. So please, Engineer Jamil, you can start and share your screen.
Okay. Thank you, Musab, for the introduction. I'm glad to be here with you. First, let me share my screen. Okay. So, within this context, let me first introduce myself. As Musab mentioned, I work in this field of innovation and management, and I have also a degree in electrical engineering, where I used to work in the R&D department of Siemens in developing new solutions, mainly in the telecom sector. As Musab mentioned, Epticar, we focus on the area of innovation and entrepreneurship. We develop programs in this field to support the startups, companies, and organizations in developing their innovation strategies. And part of that, that's why we were interested in such a project, because it's in line with our scope of specialization in the innovation field and the new technologies related to smart grid and combining it with the digital field. So this is what we do for our daily business and activities. But before I go into the business model, I'd like to thank the colleagues from the university who developed different approaches. I would not go into talking about the details of the paper or the business model. I will go into more some concepts related to this peer-to-peer electricity sharing. This is the idea or the concept, what we have currently in Jordan and in most of the developing countries, which is the centralized power generation and distribution network, where everyone is connected to central power generation. While in the future, with the introduction of the renewable energy and all this kind of different sources, different elements, where the need become more important for the smart grid to balance between the loads, to have different sources of electricity that is fed into the grid, the storage. All this put us in a different and new structure of the grid, which needs more, I would say, freedom for users and for people in order to use and utilize their own sources of energy when they feed it back to the network. And this is the concept of this project, the peer-to-peer trading. And in Jordan, we see this is the challenge in different fees and changes and different challenges related to the production or the consumption of the electricity locally, even with new trends related to exporting the energy. So this is a main challenge which needs different kind of management structure, this is why also we found it more interesting for Jordan to have this peer-to-peer energy trading concept, because of the new introduction of the renewable energy, as well as the limitation of this or the kind of policies limiting the renewable energy in Jordan. But it's also an opportunity. It's not only can be considered for the trading between households or organizations, but it's also can be used with e-mobility, with the electric vehicles, with the energy storage. This is the areas that might be interesting and supporting the electricity or this concept in Jordan. And although it might need some kind of changes in the infrastructure, but still can be easier because we already have this kind of storage. We have all the vehicles with the systems. So this is an important factor for the project, but it will add as well, not only in Jordan, but globally, this concept to give them, as I mentioned, the freedom, different opportunities for sources of energy, different ways of sharing or selling or utilizing the extra energy, because as you know, currently it's only one I would say one customer, which is the grid or the company that you feed into this company grid, and this is all what you have to do. But within the peer-to-peer, this is an extra value for the producers or the home producers. Besides that, for the distribution or generation companies, or this is an extra benefit for them, yes, through the smart grid, but from the peer-to-peer, that you can manage easily and monitor the energy, and you can monitor this on the last mile end of the grid. It's not only to the I would say the edge, but it's directly to the households. So you can monitor this easy, because you know who is producing and who is consuming. And on top of this, it could be an extra revenue stream for the operators, for the grid operators, for the distribution companies, because they can charge more fees for this kind of trading mechanism. So this is part of could be the business model that can be used by these companies, besides the home users or producers. So within this solutions, what we try to further develop from this project is, as what was explained, the software, the platform based on the blockchain algorithms, different trading mechanisms, but also there be specialized hardware devices to monitor and give the feedback based on the IoT, based on different algorithms, based on the location of these devices. And what's interesting is what was also explained, the online marketplace, where it can add value to the peer-to-peer trading, also the energy storage, which is also a challenge now. All extra energy in the morning, for example, when we use the solar panels, it's stored within the grid, and there is extra cost, the technical challenges, that the balancing, when, how to feed in, how to monitor this. This is a challenge, but within this kind of software and platform could help to allocate this kind of storage systems. And was also mentioned the vehicle charging, where you can not necessarily charge it always at your home, but you can charge your car from wherever you want, using the electricity that you generated. So ultimately, this could be an area where the online platform can be used. So it's not only offers and bids and requests. So this is practical approach, which can be charged. So these are mainly the sources of revenue that could be used for this kind of project: the subscription for the producers and consumers, the subscription for the companies to understand also the behavior at the last end. So this is basically in brief, kind of business model that might be suitable in Jordan. I would not talk about the challenges that might, not the technical challenges, but the regulatory challenges, which we were facing a lot during the past few years in this regard. So this is basically my intervention, and I'll be glad to have your questions as well. Thank you, and I would give the mic back to Musab.
Thank you, Engineer Jamil, for the informative presentation. Now let's please welcome our presenter, Dr. Hani Mohsen. Dr. Hani Mohsen is an associate professor in mechatronics engineering department at German Jordanian University. He held several administrative positions such as exchange coordinator of mechanical engineering, the dean assistant for quality assurance, and currently a vice dean of student affairs. The interest of Dr. Mohsen focused on electrical energy engineering field, renewable energy, smart grid, and design optimization. Dr. Mohsen published more than 15 papers in international journals and conference proceedings. Dr. Hani will present the future work possibilities for this field. Dr. Hani, make sure you are unmuted and again, please share your screen.
Yeah, thank you, Musab. Can you hear me?
Yes.
Okay, thank you, Musab, again, and thank all the team members. And I would like to thank all the attendees for attending this closing webinar. Today, I will talk about the future work possibilities, which are related to the peer-to-peer energy trading. And I would like first, before I start with the future work possibilities, I would like to sum up some few ideas for the attendees, okay, explaining what other members mentioned during this webinar. So let me start first of all. I would like to talk quickly about peer-to-peer trading. As Engineer Asma presented, that the peer-to-peer trading is known as the operation of buying and selling energy between two or more grid-connected parties participating in the electricity market and gaining incentivized profits. Okay, as we said before, now the peer-to-peer trading came as an alternative for the feed-in tariff to allow the prosumers to engage in the energy trading. And we know that the prosumers stands for the consumer plus the producer, due to the ability of the consumer in the smart grid, let's say, technology to generate energy using different renewable energy resources, as Engineer Asma presented in her presentation. And we also, due to the development of the energy generation and smart grid technology, the peer-to-peer will allow prosumers to dynamically engage in the energy sector, either in the trading extra energy or decreasing the demand. And also there is an importance for the peer-to-peer energy trading, as Engineer Jamil presented in his presentation graciously, that the retailers, the generators, and the distributed network system providers, all of them, they can save money by cutting the peak demand and operational cost and lowering the investment cost, and finally increasing the system reserve and increasing the PV system dependability. Sorry. Okay, now let me start, okay, with, let's say, the structure of the peer-to-peer energy trading. Now we have two levels of peer-to-peer energy trading. We have the virtual layers and we have the physical layer. Okay, what are the difference between the virtual and the physical layer? The virtual layer represents the first level of the peer-to-peer energy trading, and it includes the information system, market operation, pricing structure, and energy management system. And when we talk about the information system, we are talking about the performance and the secure of the system, which must lies at the core of the peer-to-peer system. And there are many tasks that involved within this information system. such as accepting all the market suppliers to interact with each other, to contribute into peer-to-peer energy trading, also to incorporate with the suppliers, providing an equivalent access to the common market and supervising the market operations, and finally, to guarantee the network reliability. Okay, the second point is the market operation, which belongs to the virtual layer. And this layer, again, is this section is important because it includes the market functionality in terms of the market allocation, and also the bidding structure will be defined here, and the payment regulation. And the third section is the pricing structure. And here we need also to make the pricing procedure in order to balance between the energy demand and the supply efficiently. And finally, the energy management system. And here we mean that we need to control the purchasing and the selling based on the cost of energy. The second layer in peer-to-peer energy trading is the physical layer, and this is represent the grid connections, communication infrastructures, and metering. And finally, there's another, maybe not layer, another components which belongs to the peer-to-peer trading, such as the market participants and the energy trading's regulation. Okay, now if we want to look to the challenges that exist in the virtual layer, there are some challenges that have to be tackled when we consider the virtual layer, such as minimizing the energy cost, balancing the energy demand and supply, incentivizing and engaging the prosumers, and upgrading pricing mechanism, and finally classifying the uncertainties and asynchronicity. Regarding the physical layer, the challenges now which exist in peer-to-peer, let's say, which stand in front of the implementation of peer-to-peer trading, such as the violation of the capacity and the voltage constraint, the rise in the network power losses, losses of the system strength, and securing the transactions, and finally ensuring the network stability. As Engineer Muhammad explained in his presentation, there are technical approaches which belongs to the peer-to-peer energy tradings and can be mainly divided in the literature to the game theory approach and to the double auction market. The game theory approach is applied to the physical layer in the literature and also is applied to the virtual layer. The double auction market is also applied for the physical layer and for the virtual layer. Okay, now in terms of optimizing the peer-to-peer energy trading, also there is a constraint optimization which must be considered for the virtual layer and for the physical layer. Okay, if we want to consider the aspects which have been considered in the literature regarding this optimization, there are many tools have been applied, such as the linear programming, the mixed integer linear programming, and the ADMM, convex optimization, the neuro-linguistics programming. All of these tools have been utilized to perform the peer-to-peer energy trading with constraint optimization. Okay, Engineer Asma also mentioned the blockchain systems. And again, these the topics that have been mentioned in the literature regarding the blockchain system, such as the smart contract, the ELEC-BAY, which is related to the microgrid and must consider the network restrictions to accept and or to reject orders, which means that before accepting or rejecting the ask and the offers from the prosumers, we have to consider the network restrictions or limitations. And there's also the consortium-based blockchain. We have the Hyperledger. We have the Ethereum. The Ethereum, it's similar to the Bitcoin, which can be used as, let's say, the currency which is used in the peer-to-peer energy trading. All of these topics have been mentioned in the literature as blockchain systems that can be used with peer-to-peer tradings. Now, there are some novel techniques which recently have been seen in the literature and discuss the implementation of the platform for peer-to-peer trading, such as the graph theory, the artificial intelligence, the multi-agent heuristic simulation, and the activity-based models. Okay, So in the future, in order to see what are, let's say, the topics which or the gaps which have not been covered in the literature, so we can let's say cover the study of peer-to-peer and hybrid framework for large and larger number of participants. We can also maybe make a study on develop a suitable business model for developing countries regarding the electricity pricing strategies for trading energy with restricted policies, particularly between nanogrids. And there is also an option for the research which is related to evaluate several auctions and bidding strategies to find the proper mechanism with extra attention to the intelligent bidding strategy, dynamic auction, and smart contracts. Also, we can work on focus on using distributed methods in building a trading platform for multiple buyers and multiple sellers negotiation. And also we can use artificial intelligence in the decision-making stage during the trading process. Actually, this is not all the possibilities which can be investigated in peer-to-peer trading. There are also many, let's say, opportunities which can be investigated, such as the network charge recognition. Here we are talking about that the prosumers do not normally utilize an entire energy network for peer-to-peer energy trading. So we are not talking like the typical power system. Here we must investigate the change, the perception according to what they are charged for the power bills, so they can be charged under the peer-to-peer trading concept. Also, there is an option for studying the large-scale network trading and simulations. There's also an important aspect which is not covered in the literature, such as the grid benefits. Most of the studies, they are covering the impact of the peer-to-peer trading in terms of the, let's say, prosumers, but nobody considered the impact of the peer-to-peer trading on the grid. What are the benefits of peer-to-peer trading on the grid side? Again, there is also another opportunity, such as studying the multi-level storage facility in order to balance always between the demand and the supply. There is also prioritization of the stakeholders that can be considered also in the research, also the market mechanism and limitations. So this is most of the points that must be covered in the future in order to say that we cover the peer-to-peer trading, considering all the aspects. As I said before, we have to consider the virtual layer, we have to consider the physical layer, and we have to study the benefits of the peer-to-peer trading in terms of the prosumer sides and into the distribution, let's say, networks, which will be benefited from peer-to-peer trading, or otherwise it will not be, let's say, a complete solution, I mean, for the future applications. Okay, now we expect that one of the challenges which we can find here in the implementation of peer-to-peer trading in our countries or in developed countries in general is the centralized utilities control. So we expect that the market maybe refuse the installation of decentralized trading market. So to get existing utilities cooperation, it must be ensured that many extensive research must be proposed. And also there are some trading policies and regulations that must be, let's say, established before moving towards the peer-to-peer trading. Yeah, and this is what we expect to, let's say, as a challenges here in Jordan for implementing peer-to-peer implementation in Jordan. Okay, that was my presentation, which are related to the future work that can be done in the future regarding the peer-to-peer trading. Thank you very much, and I'm happy to receive any questions from your side. Thank you.
Thank you, Dr. Hani. Thank you very much. We are now going to the open discussion. As a reminder, you can still submit questions through the chat area. Now, let's please welcome Dr. Makawi Hrez. He will join Dr. Hani to moderate this part of the webinar. Dr. Makawi received the PhD degree from the University of Cádiz, Spain, in 2021 He is a researcher in the electrical department at the University of Kadesh, and he is currently a visiting researcher at German Jordanian University. He held the director of Industry Synergy Center at Palestine Polytechnic University. Dr. Rehrez is a certified trainer by Schneider Electric Company to conduct seminars and training courses for all variable standard drives related topics. His research interests focused on the influence of photovoltaic systems on the distribution network using evolutionary algorithms and smart grids. So please begin, Dr. Makkawi, and you can share yours.
Thank you very much, Engineer Musab. I will to talk about in our presentation about peer-to-peer requirements. In peer-to-peer requirements, there are 4 important checklists. The first talk about technical requirements and policy needed is very important, and the regulatory requirements and stakeholder rules and responsibilities. For the first categories about technical requirements, we talk about hardware. Dr. Hani talk about mention about virtual and physical layer. In there are 3 in technical requirements is very important: hardware, software, communication, and protocol. For hardware, talk about a physical layer is very important about a smart meter that can help monitor real-time power production and smart grid, including a microgrid, nanogrid, and mini-grid. For virtual layers, talk about information and communication technology to enable communication between the participant, monitoring, and energy management system. This is for first of technical requirement. The second in technical requirement is about hardware. The second is the software. Software talk about the first important point is a platform for peer-to-peer electricity trading. We will work in this our project. And the second is advanced power demand and supply forecasting analysis. And we need important to data robust analytical tools. And the final in the software, we need algorithm for automated execution of peer-to-peer transaction or blockchain technology for reduces transaction cost. And the second and the third important technical requirement is about communicational protocols. In communicational protocol, we need a common interoperable protocol for coordinated among system, network, and market and the platform operator. And we need protocol communication between consumer and consumer. This is 3 issues important in technical requirement. For the second checklist or requirement for peer-to-peer is policies needed. In this policies needed is the first important. We need policies supportive, encourage decentralized of power systems and better utilization of existing grid infrastructure. And the second, we need encourage pilot program to work as a test bed in regulator as sandboxes and dissemination of this result. And the important policy to improve the access the capital for platform developer. The third checklist and requirement for peer-to-peer is regulatory requirements. In this issue, the first talk about retail market. The retail market talk about enable trade of power among consumer and consumer without renewable energy capacities generation, and establish regulation on data collection and access. We talk about as well as cyber security and privacy for platform for owner and developer and the platform member for peers. The second, we need define a clear rule and responsibilities of stakeholder involved in peer-to-peer, and ensure that consumer rights are respected by stakeholder in peer-to-peer schemas. And the final, define market operation rules for peer-to-peer scheme. When talk about distribution network, we talk about 3 points. This point for checklist is enable distribution system operator to record flexibility for peer-to-peer platforms, and we need to determine the network charges between peer-to-peer trading is using in the main grid. And the important point, we need to define the technical criteria for the service needed in the distribution network is very important in any system peer-to-peer for that. In the last checklist, talk about regulatory requirements. In this issue, first talk about consumer and consumers. It's important to engage in peer-to-peer electricity trading between consumer and consumers, and provide a service to the power system either individually or via retail or aggregator between consumer and consumer. And talk about peer-to-peer platform or market operators. Is important to develop and operate a platform for peer-to-peer trading with information and communication technology components. And important point for the platform, and this is important point, talk about security and trusted platform for all users and consumer and producer and other company. This is short presentation about requirement of peer-to-peer specialist. Thank you very much, everyone. And now we start for question, open discussion.
Okay, Musab, we can start by reading the messages on the chat zone.
Yes, Dr. Hani, if you want, you can read or to moderate.
Okay. So
This,
let's start
session.
with the first question. Is it? I think it's from Muhammad Al Momani. It's related that. Okay, sorry. It's from Dr. Ghaib. Okay, he's asking about if there is a technical issue, for example, that assume one prosumers inject the power due to demand from another one in the same moment. Another peer-to-peer process is going on. How we can maintain the stability of the network, busbar voltage, and reactive power flow due to the mass trading at the same moment. Here, I think it's not possible to make 2 processes at the same time, because usually when you receive offers from, let's say, prosumers or consumers, we actually, let's say, we are ordering them these orders, let's say, or the ask in the descending order based on the expected prices. And the producer will also send their offers. So we order them in ascending, let's say, order. And based on the, let's say, the matching point between these 2 curves, okay, this is which will make the process of the transferring the power. So at the end, there is only one process which happened at the same time, okay? But if you mean, if there is another process with another, let's say, prosumers, okay, you are talking about the physical, let's say, challenges in front of implementation of peer-to-peer trading, which I mentioned during my presentation. I said that we have to consider the impact of the peer-to-peer trading on the network. So for instance, if you are applying the peer-to-peer trading on different phases, this is maybe will result in imbalance in the phase voltage on the 3-phase system. So this issue is, let's say, it's legitimate that we have to consider the phase balance, and in order to ensure the stability of the electrical network. And I hope this answers your question, Dr. Ghaith. And Dr. Ghaith, you are welcome if you want to ask also in Arabic, or any of the attendees also. Okay, now Dr. Ahmed Al-Baghdadi is asking about has there been any contact between local authorities regarding this matter? Okay, now at the current phase, we are only investigating, let's say, the peer-to-peer trading as, let's say, research. We are at the research level. When we finalize the concept, we will try to talk to the authorities in order to check if this is applicable, or what are the modifications we need to do in order to make this project fit with the Jordanian government requirements. I hope this answered your question, Ahmed. If not, you can ask. Mu'taz, Engineer Mu'taz,
Dr.
is
Hani,
asking. تفضل.
before Ahmed Baghdadi, there is a question from Ahmed Al-Mumani.
Sorry, I'm trying to find it. Okay. Okay, how companies will benefit from this project? Okay, as I said before, at the end, when we finish the research, let's say state, maybe at the future in the Jordan, we will have some retailers who want to sell, let's say, power or energy for the prosumers if the government apply the peer-to-peer energy trading. And this will be helpful that we designed a platform which can make these companies understand how the peer-to-peer trading is happening and how we can apply it on the, let's say, on the electricity network. So it's like we are making the infrastructure for peer-to-peer trading in Jordan. So it's not finalized, but at the end, we can give them the infrastructure which they can start from and build on it. Okay, now we move to Engineer Mu'taz. تفضل.
May I elaborate more about the questions that you have
Yes,
answered?
please.
Okay. With regards to the question of Dr. Ghaith about the stability of the system, when we talk about peer-to-peer energy trading, we talk about an on-grid system or on-grid network. So consumers will inject their surplus electricity to the network, and the consumer will consume from the network. So this process will incentivize consumers and stakeholders to invest in renewable energy system. But as you mentioned before, there will not be any interference between two processes at the same time.
Yeah. But I understand his question also, Engineer Muhammad, that he means, for example, now we have two peer-to-peer processes happening at the same, let's say, node or bus bar.
Yes.
Okay. Now this will impact the stability of the network because, as you remember, that we talked about the phase imbalance. This will make phase imbalance also on the network, and this must be investigated. And that's why I said in my presentation that the benefits of the peer-to-peer trading in terms of the grid side, must be considered deeply, because nobody, let's say nobody, it's a few research have been established regarding this issue. What are the impact of the peer-to-peer tradings on the, let's say, technical side or the grid side?
What he is supposed as a question is that calculations and power system load flow analysis should be studied. We have a research paper that we have talked about, which employ an algorithm to carry out an investigation before doing any transaction. So a successful transaction is that with smallest losses. So doing calculations and power flow analysis is also possible before making any decision.
Okay. But
okay.
As I said before, is this enough to ensure the stability of the network? Is just only doing the load flow?
This technology is still at the beginning. And,
yes, I know.
As you mentioned before, future work should be intensively carried out in this regard.
That's true. Okay, good.
Yeah.
Thank you for your comments.
Another question is for Ahmed.
Ahmed, we answer. Okay, it's
yes.
about
it's about how companies can benefit.
Yes.
Also, the network or the operational aggregator or the operational network can benefit from employing charges on every transactions, so they can make business from these charges.
Okay, but I said in the future, maybe this is because it's not applicable until now. Okay, but so in terms of our project, we are doing, let's say, a study for the future for these companies, which can build in or on to complete their, let's say, investigation of the investment in such companies in the future, maybe. What do you think? Okay. Inj Muhammad, are you with me?
نعم, yes.
I mean, I'm asking you, what do you think?
About, please, could you please?
I mean, in the future, if
Mhm.
there are some companies which are interested to invest in Jordan in establishing, let's say, companies for selling the energy, okay, I think they can rely on our project to use
Yes.
it, yes, for the
Yes, of
future.
course.
As
This
yeah,
is as a base infrastructure for any future pilot project in
exactly.
Jordan. Yes.
Yeah. Now we move to Engineer Mu'taz. He was asking about if one of the loads or house takes from two sources, the linkage device will secure synchronization between the two sources. And if the purchase price of the electricity is unfair, especially in the period of the energy crisis, by the companies, will this system be financially feasible for producers? Okay. Okay, if one loads. Did you get it, Mohandas Muhammad? If one of the
1
loads
minute,
or
please.
yes, I'm trying to understand the question.
If one,
I think he asked about the sources that consumer can get electricity.
Okay, maybe he means
Yes.
if you are
Yes.
your demand is covered by two sources.
In peer-to-peer electricity trading, you have to choose which source you have to connect your, or which source you have to receive electricity. You should not receive from two sources at the same time. Once you do not buy or submit bid or yani submit bid to request electricity, so automatically will buy electricity from the general network, but the price will be different.
but in the future, it's possible to take from two sources for house.
Two sources if we have two different meters. If we have 1 meter, the 1 meter can trade only with one partner or with one peer, sorry.
But
So-
actually, it's interesting questions. For example, if your demand can be covered from two,
Source.
let's say, sources, is this possible to do it in peer-to-peer trading or not?
but not at the same time.
Okay,
At the same time, you only receive the electricity from one peer. Once this peer has insufficient electricity, so you can meet your demand from buying electricity
the rest from the
another
company.
peer, from another
Oh.
peer, or even from the network.
Okay, okay.
But the thing that is different is the price. So you will buy with certain price from the peer, and the price when we buy from the electricity network will be different.
Mhm.
Maybe higher
Interesting.
than buying from, yes.
Okay, there's a question to Engineer Asma. It's from Ahmad. The question is, how can the IoT be implemented in the smart grid systems?
Yes, Doctor. Thank you, Ahmad, for your question. And excuse me all for my voice, I'm a little bit sick. So what is the question again? How can the IoT be implemented in the smart grid system? Okay, I already covered this, but maybe you missed it. So IoT can be used, as I said, to acquire data from transmission lines, from generation side, from transmission also. So it can be used to monitoring generation from different kinds of power plants. Also, it can be used to predict the necessary power to supply consumer. As I said before, also it can be used in the customer side to measure different type of parameters and to managing the energy efficiency and power demand. So IoT, it's a big concept, so it can be used in different side and different stages. I hope I covered your question.
Al-Momani asked also about the courses.
if the course is available. Anyone?
Is it available to anyone? Yes.
Yes.
It is available to anyone who is interested in blockchain, IoT, smart grid, and related topics.
Is it possible to share the link with them here?
Yes, we have already shared the link.
Shared it. Okay, good. Okay. Is there any questions? We are open to answer your question if it's written or if you can also talk. Okay. So Mus'ab, do you hear me?
Okay, Dr. Hani,
Mhm.
if there is no questions, we can end this webinar. Okay, dear attendees, if you have questions we didn't get to today or think of new questions, please contact me at the address shown on the chat area. We will provide you with the recording of this webinar and the presentations of in a few days. Thank you, presenters, Dr. Hani, Dr. Mukawi, Engineer Jamil, Engineer Muhammad, and Engineer Asma, and Dr. Ala Al-Halhouli. And thank you, everyone, for attending today's webinar, Peer-to-Peer Electricity Trading and Microgrids Platform Launching. On behalf of Smart Grid Lab at German Jordanian University, thank you for joining us today and have a great rest of your day. Thank you very much.
Okay, thank you, Mus'ab, also for organizing this event. Thank you very much.
Thank you,
You're
everybody.
welcome.
Thank you. Thank you very much.
Thank you.
Thanks.
Okay, bye.
Still waiting.